So complex numbers, this is section 1.6, so right, you should have attempted at least to leverage this content before this class session, and so you should be familiar with what we're about to talk about. So the form of complex numbers, generally speaking, is a plus bi, and you can read right there, a and b are real numbers, and I squared is equal to -1, meaning that I is equal to the square root of 1. And imaginary numbers come up in physical systems, often relating to trig identities. And so you end up with imaginary numbers in engineering vibration as a way to describe oscillatory motion. And although they're complicated and unexpected, they are extremely needed and useful in solution of complex problems. So looking at this, the imaginary part and the real part of a complex number, it's made up of two pieces. There's a real part, right, that would be without the I, and the part that is imaginary would be B, which is associated with the I. So as an example, for 4 plus 9i, so the real part of this complex number is 4. The imaginary part is 9. So imagine a complex number, a plus bi, has a conjugate, and this is going to be called the complex conjugate. You know, we put the bar on top of it, and then we just flip the sign associated with the imaginary term. So whatever z is, whatever the sign is in the number z, so here it's positive, so z bar would be the conjugate, and it would have a negative. That would be different. If this was a minus bi, then this would be a positive on the conjugate. And the reason why the conjugate is so useful is that z times its conjugate, any complex number times its conjugate, always ends up as a real number. So we use this to evaluate complex numbers being divided by each other. So let's take a look over here on the left. So we want to express this fraction in the form of a plus bi. So we have an imaginary number in the denominator. So the way that we're going to handle that is by multiplying top and bottom by the conjugate, the complex conjugate of that number. So we're going to multiply top and bottom by 1 plus 3i. So I'm just going to highlight the top here. You can go back and follow the bottom, but you can see how the imaginary parts cancel out, plus and minus, and then you end up with a I squared, which gives us -1. So you can follow that on the bottom, you get a 10. Let's just highlight the top here. So we have to use the FOIL method. So I'm going to go this way, 1 times 5 and then 1 times 6i. So I end up with 5 plus 6i. And then I'm going to be multiplying the 3i times the 5. So plus 15i. Then the very last term would be 6i times 3i, which is going to give us plus 18i. So I'd encourage you to take your time, have your space that you need. And at this point, now we're going to start collecting terms. So 5, this I squared is equal to -1. So we got -18. So I'm going to bring that forward. And 6i and 15i give us 21i. So we just combine the 5 and the -18. That gives us that number. So there is this number, right, expressed in the form of a plus bi. So should go really one more step. It would be minus 13 over 10 would be a, and then plus 21 over 10i. Let's do it right here as well. So 13 plus 11i divided by 4i. We're going to put it in the form of a plus bi. So we're going to multiply by 4i. There's no reason you could use the conjugate if you wanted to, but because there's no real part, we can just multiply by the imaginary part, and that'll take care of the denominator. So I'm going to just focus on the denominator here. You can go kind of chase the numerator. So 4i times 4i is going to give us 16i squared. I squared is equal to -1, and go ahead and now I actually did it. So it's 44 over 16 reduces to 11 over 4. And then negative negative would just give us a positive. Positive 52 divided by negative 16 would be negative 13 over 4i. So you can go ahead and pause it if you need. So careful of the square root of negative numbers. And we'll take a look at an example here. The square root of a times the square root of b is equal to the square root of a times b when a and b are both positive. Not true for a and b, negative. So let's go take a look here. Let's say we've got square root of negative 4, so a is negative 4 and b is negative 3. That on the other side would give us square root of negative 3 times negative 4 underneath the radical sign, so that gives us square root 12 over there. On this side, let's go ahead and rewrite it as I root 4 and I root 3. That's going to give us I squared root 12, and I squared is negative 12. So this is not true. This is not true when a and b are both negative, so just keep aware on that. And now I've got a big example in front of you, so multiplying out these two terms and going to put it in the form of a plus bi, and you see that all the way down here. And this example is a bit long, but what I want to encourage you is do not skip steps. Let yourself let yourself have the space that you need, and that's going to give you a chance to follow your answer correctly. So all I do is just FOIL this. So I multiply there, right? Multiply there, gives me that term. So I'm just carrying all the negative sign. There's the negative sign carries. I'm going to go there to there and there to there. So it looks kind of weird. I got negative and then square root negative 7, square root negative 9. So at this point, I just need to simplify. So the 9 catches my attention because I know that's going to be a 3. 63 should have caught my attention maybe one step earlier, but then I realized that it's 7 times 9. 9 times 7. So I'm able to get here, square root 9 times square root 9 gives me 9. Right, this one just carries all the way down, nothing to change there. Here I'm able to get the 3 out, so I get a 3 times 7, square root 7. And let's take a look at this very last term here. So negative, right, square root negative 7 times square root negative 9. Take the i's out, right? I squared is equal to negative 1. Right, square root 9 is 3. And so now finally I get to that right there. That was the step I was looking for. I've got all square root 7s, which obviously makes it a little bit easier. I could I could factor that root 7 out down here on the bottom, but now I've got kind of my constant terms, right? My real terms, and then my imaginary terms. So I'm just going to take 21 and 3, add them together with the root 7, and then the minus 7i and the plus 9i, so plus 2i root 7. So kind of lets you see that you want to get your rhythm. You want to be able just to be in control of that math, and I would encourage you to take that much space so that you could go back and check your work, kind of like I just did with you. Instead of creating it on the fly. So I'll give you a second there. You can just pause it if you'd like. So the other place imaginary numbers come in is right here in the quadratic equation, the determinant. If that's less than 0, right, then our answer is going to be the x answers. Right? The imaginary roots are going to be complex conjugates of each other because of that plus minus sign that shows up in the quadratic equation. All right, so then the last one, just going to simplify, right? Simplify and essentially end up in the form of a plus bi. So I'm going to take that and just going to go ahead and multiply top and bottom by the conjugate. And I'm going to go ahead and chase the top here again. You can kind of pick up the bottom on your own. So that first term would be 3 times 3i. Second term would be 3 times plus 2, or plus 6. Minus 12i, right, would be the, minus 12i squared. Sorry, the minus 4i times 3i. And the last term would be minus 8 right there. So I've just FOILed that. And so I got i's for that. That's going to be negative 1. So I just got to be deliberate enough to see that I've got, here I've got 9i, oops, here I've got 9i minus 8i giving me I. 6 minus 12 times negative 1, that's the I squared. And then that simplifies to 6 plus 12. And so I plus 18 divided by 25. And so we can go back and see the denominator, right? It's going to be 3 times 3. We know that there's going to be a plus 12i and a minus 12i. That's going to cancel. And then the last one will be minus 16i squared. So minus 16 times negative 1. So that gives us 25 down there. So there's our simplified version right here. We went from something that had an imaginary part in the denominator to something that is in the complex number form.